Hello everyone, welcome to our last video in chapter 5, the first chapter in the unit of electricity. In this video, we will be able to know the difference between series and parallel connection. If you have any question, don't hesitate to contact me via WhatsApp. I will be answering as soon as possible. I hope you will enjoy this video. In this video, I will first go over a small review about this chapter. Then I will explain briefly what is the difference between series and parallel connection. After that, I will explain how voltage and current varies in both connections. Then, I will show you a small video to illustrate the two connections. After that, I will finish with stating the rules and the laws used in each connection. In this chapter, we know that voltage is the potential difference between 2 points, or the 2 poles of an electric device. Besides, we know that current is the flow of electrons. Then we studied that voltage is measured by a voltmeter, and its SI unit is volts, symboled as V. However, current is measured by an ammeter, and its SI unit is ampere, symboled as A. In this video, we will learn how to differentiate between parallel and series connections. Parallel connection usually has the same shape as the equal. In this connection, we have voltage is equal in the parallel branches. However, the current is additive, which means the sum of all branches is equal to the main branch. We can say that the voltage of the main is equal to the other branches, which is V equal V1 equal V2. And we can also say that the current of the main branch is equal to the sum of the other branches, which is I equal I1 plus I2. Series connection is when all the components are on the same wire or line. In this connection, we have the current is equal in all components in the same branch. However, the voltage is additive, which means the sum of all the voltages of the components is equal to the voltage of all the branch as a whole, or is equal to the battery or the generator. We can say that the current in the same branch is equal to the current in each component in this branch, which is I equal I1 equal I2. And we can say that the voltage of the battery is equal to the sum of the voltages of the components, which is V equal V1 plus V2. Now we are going to see this small video in order to illustrate the idea of parallel and series connection.
There are two main types of electrical circuit, series and parallel. In a series circuit, the components are connected end to end, one after the other. They make a simple loop for the current to flow round. In a parallel circuit, the components are connected side by side, so the current divides, some going one way and the rest the other way. Here's an example of two circuits, both containing a cell and two bulbs. One circuit is series, the other is parallel. The voltage is a measure of the electrical push that the battery gives to the electrons. It's a measure of the energy in joules given to each packet of electrons, coulombs. So the voltmeter measures joules per coulomb, or volts. Voltmeters are always connected in parallel when added to a circuit. In this diagram, the voltmeter is measuring the voltage across the lamp. We can also measure the current flowing through a circuit. In a wire, the current is the flow of negatively charged electrons. We can imagine it being like water flowing in a pipe, but instead of water, it's a flow of electric charge, which we measure in coulombs. So electric current is coulombs per second, or amps, measured using an ammeter, which must be connected in series. For components connected in series, the total voltage or potential difference of the power supply is shared between the components. There is the same current through each component. For components connected in parallel, the voltage or potential difference across each component is the same. The total current through the whole circuit is the sum of the currents through the separate components.
After seeing this interesting video, now we know the relation between the voltage and the current in each branch in parallel and series connections. So, what is the relation between the voltages in each branch in parallel connection? Correct, it's equal. This is called the law of uniqueness of voltage in parallel connection, where V is equal to V1 equal to V2 equal to V3. And what is the relation between the current in each branch? Correct. Current is equal to I1 plus I2 plus I3. This is called the law of addition of current in parallel connection. Now we have the series connection. What is the relation of the current in each component? Correct, the current is equal. This is called the law of uniqueness of current in series connection, where I equal I1 equal I2. And what's the relation of the voltage in each component? Yes, the voltage is additive, which means V equal V1 plus V2 plus V3. This is called the law of addition of voltage in series connection. After we finish the explanation and have seen the video and the conclusion, now we are able to solve these small questions. Please choose the correct answer in each. Thank you.